Okay, this video is going to cover negative exponents and scientific notation. So our negative exponent rule states that if any number, variable, whatever is brought to a negative power, then we push them to the bottom to become positive. So that becomes 1 over b to the positive n when we put him on the bottom. So just like our friends, if they are negative in our lives, we just want to push them to the bottom of the friend list until they become positive again. And then that works both ways. So if it's negative on the bottom, then they come up to the top to be positive. So this is the exponent rule that you need to know for this section. But first, our joke of the day. Why didn't the number 4 get into the nightclub? Because he is too square. Okay, so let's work a few problems just knowing with what we do with our negative exponents. All right, so the first example, 6 raised to the negative 2 power. Well, that means we're going to put him on the bottom, which means 1 goes on the top, 6 is on the bottom, now with a positive 2 exponent. Well, 6 squared is 36, so that becomes 1 over 36. 5 raised to the negative 3 power means we're going to put him on bottom to become positive, and 5 cubed is 125. Okay. So negative 3 raised to the negative 4th power. So remember, negative numbers are okay. It's just that negative exponents are the ones that are being moved. So this means we're going to take negative, well, let's do it this way. 1 over negative 3 to the positive 4th power. Well, remember, that means negative 3 times negative 3 times negative 3 times negative 3. Well, that is positive 81. So that is 1 over 81. So here's one where the negative exponent is on the bottom. So 1 over 2 to the negative 3. And that means he's going to come up top to become positive. So 2 cubed means 2 times itself 3 different times. So 2 times 2 times 2, which is 8. Okay, well, here's a fraction. 2 is raised to the negative 3 power over 7 raised to the negative 2 power. Well, let's just take one at a time. He needs to go on bottom to become positive. The 7 raised to the negative 2 power needs to go on top to become positive. So 7 squared over 2 cubed means 7 times 7 is 49 over 2 cubed, which is 8. Final answer. Okay, but here's a little shortcut. So if you've got 4 over 5 and it's raised to the negative 2 power, remember that our other exponent rule that says anything inside those parentheses is raised to that power. So that means 4 is raised to a negative 2 power and 5 is raised to a negative 2 power. Well, we know that we've got to push the 4 down to the bottom to become positive. But we also have to move that 5 to the top to become positive. So that makes 5 squared over 4 squared. So notice we basically just flipped this fraction and then brought it to the positive power. So you could take that little shortcut. If something is inside parentheses brought to a negative power, especially if it's a fraction, then you can just flip that fraction and make it positive. So that ends up being 25 over 16. 5 times 5 is 25. 4 times 4 is 16. So it's that final answer. Okay, so look at this. 1 over 7y to the negative 2 power. So pay very close attention using those parentheses and things that we've talked about before. What is brought to the negative 2 power? Well, just this y is. The 7 is not. So the 7 has to stay where he is, but the y to the negative 2 needs to go to the top to become positive. Well, then we don't really need that 1, so we could just say y squared over 7. So just notice that 7y is not in parentheses, so only what's next to that exponent is what's brought to that power, which is that y, not the 7, so he needs to stay there. Okay, so maybe you've already figured out how to do this one. This is just going to be then y to the 8th over x. And we don't have to write that 1. It's just an imaginary 1 when nothing is there. So if you want to, you can, but you don't have to. All right, so let's talk about throwing some of these exponent rules together and see if we can simplify some of these expressions. Well, we have x to the negative 12 times x squared. Okay, so what's the rule when we multiply that same base with exponents? We add them. So we're going to say x to the negative 12 plus 2. Well, that makes x to the negative 10. So now we need to figure out where we need to put this, because we do not like negative exponents. Negative exponents are never going to be an acceptable answer except in scientific notation. So you always want to make them positive. And in this case, we know we'll push that x to the 10th then to the bottom so that that exponent is positive. Okay, so over on this one, what do we do when we divide? Well, it's always top minus bottom. When we divide those exponents with the same base, we subtract. So that's the top minus bottom, so x to the 2 minus 10. Well, that leaves us with x to the negative 8. Well, he needs to go on bottom to become positive. Okay, so let's look at another example. We have 75x cubed divided by 5x to the 9th. Well, we're still going to divide our numbers just like we normally would. So 75 divided by 5 is 15. And pay very close attention to whether these numbers go on the top or whether they go on the bottom. So if that is still a fraction, if the number on the bottom is bigger, it's got to stay there. All right, so then what are we going to do with those exponents? X to the 3 minus 9, which leaves us with 15x to the negative 6. So this needs to go on the bottom to become positive. So 15 is still on the top. X to the 6th, now that's positive, is on the bottom. Okay, so now this next example, we have 50 divided by negative 25. Again, remember that those negative numbers are okay. So do not think just because you have a negative number it needs to go somewhere else. It doesn't. It's still just going to be, in this case, 50 divided by negative 25 is negative 2. But y to the 8th minus 14, well, 8 minus 14 is still negative 6, so we have negative 2, y to the negative 6, so we're going to put that y on the bottom, not the 2. The 2 is going to stay on top, because that is just a whole number. He's negative. All right, so let's look at this rule. What happens when we've got something in parentheses? Remember, that means everything in these parentheses is brought to that second power. So 6 squared, and then x to the 4th is also squared all over x to the 11th. So remember that bottom, he's not in parentheses, that denominator, x to the 11th, so he does not get brought to the second power. All right, so 6 squared is 36. X to the 4th raised to the second power means we multiply. So 4 times 2 is 8. So that's x to the 8th over x to the 11th. Well, now we're going to subtract those exponents. So 36 x to the 8 minus 11 leaves us with 36 x to the negative 3. So we need to put that exponent on the bottom to become positive. Okay, so here's another one of those examples with the what's inside the parentheses brought to a power. So just we can do this two different ways. You could go ahead and do the division inside here. So x to the 8th minus the 4th, then brought to that negative 5 power. So 8 minus 4 is x to the 4th, but he's still brought to the negative 5 power, so that means x to the multiply 4 times negative 5, so that's negative 20, so that becomes 1 over x to the positive 20. And so just know if he's got to go on bottom and there's nothing, no other number or variable, you're always just going to put it under 1. Okay. So the other way you could have done that, remember, would be to go ahead and flip those and then bring that to the positive 5 power. Remember how we could do that in that previous example up top. So then you could say 4 minus 8 still, then negative 4 times 5. So you're still going to get the same answer. Okay, so let's talk about scientific notation. So scientific notation is always written in x times 10 to some power. So like when you get super rich someday and you're having to like count your money and you just are losing track of all the zeros, you're going to want to write them in scientific notation. So if n is positive, then you're moving that decimal to the right, and if n is negative, you're moving that decimal to the left. So in this example, 7.4 times 10 to the 9th, we've got this number 7.4. Well, this 9 is positive, so we're going to move this 9 spaces. 3, 4, 5, 6, 7, 8, 9. Well, that's where the decimal really goes. So look at all these zeros, and hopefully your income will look like this someday. But then that becomes our number. Oh my goodness, that's huge. So is that 7 billion? 7.4 billion right there. So that's how you would expand that number. So here's one with a negative exponent, so we're going to move it to the left. And 1, 2, 3, 4, 5, 6, and that's where that decimal should go in that number. And so you fill in all those zeros, so that number becomes 2, 3, 4, 5, 3, 0, 1, 7. So you see how it just makes the number a little bit easier to read if you actually write it in scientific notation instead of this expanded form. But I just wanted to show you how you can write them both ways. So let's talk now about writing them from the number that we have. Well, the key to scientific notation is that there is only one number to the left of the decimal sign. So in this case, this decimal has to go right here, or else it's not scientific notation. So notice how we're only going to have one number to the left of that decimal. So we're going to say 7.41 is just until we get to all the zeros, and then we're just going to list whatever is out there, but not list all those zeros. Then you say times 10. Well, how many spots did we move it? Well, if we're putting our decimal in right here, let's just count. Our decimal is normally back here at the very end, so we're going to say that's 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So we're going to put a 9 there. So 7.41 times 10 to the 9th power. So that's how you write that. All right, so this one you see is going to be a teeny tiny number. Hopefully this doesn't represent what your income is someday or your worth or anything, but where is this decimal going to go? If there's only one number to the left of it, well, it's got to go right here between the 9 and the 2. So when we write that in scientific notation, we're going to say 9.2 times 10, but how many spots are we moving this decimal place? 1, 2, 3, 4, 5, 6, 7, 8. But it's a small number. It's a teeny tiny number because that decimal is way over here. So that's that negative number. And so that's how you write them. All right, so doing computations with scientific notation isn't too bad at all. We're going to just remember everything in here is multiplied because it's 3 times 10 to the 8th times 2 times 10 squared. Well, all we're going to do is say, okay, well, what's 3 times 2? Well, that's 6 times 10 to what power? 10 to the 8th times 10 squared. What do we do with our exponents there? We add them. So 8 plus 2 is 10. So this becomes 6 times 10 to the 10th power. And same thing with division. We'll divide the real numbers and then subtract the exponents. So what is 8.4 divided by 4? Well, that is 2.1. And then we'll say times 10. To what do we do with our exponents there? That is 10 to the 7 minus a negative 4. Well, think about that. What is minus a negative? That really means plus. So 7 plus 4 is 11. So 2.1 times 10 to the 11th power. Okay, these are not too bad. This is really sort of easy. Okay, so we're going to do another example. This is a 4 times 6. So that's 24, right? Times 10 to what power? 3 plus the 9. 9, 10, 11, 12, right? So 10 to the 12th power. But what's wrong with this one? Is this correct scientific notation? No, it's not correct. What makes it correct? It's got to have only one decimal space. Well, one place to the left of the decimal. So where does this decimal need to go? Well, it needs to go between that 2 and 4. So 2.4 times 10, but if we're moving it one more digit over, what does that mean? That means we've got to say plus 1. So that becomes 13. Okay, so that's not too bad. Just remember that's sort of the key, is that it is not incorrect scientific notation unless there is only one place to the left of that decimal. So good luck on that homework. It should be pretty easy.